All right, so here's your homework for modeling with functions. So what it says is graph the following equations on the grid. The equation y equals x is already done. And then for each new equation, explain what the number 2 does to the graph. So in A, when you add 2 to the outside, what does it do? And we know that it is a vertical shift up. How many? So take every point and go up 2. Well, for a line, all I need is 2 points. Go up 2. I'll get a few more points up 2, just so I can try to be accurate when I draw it. Here, I got a ruler. So this line right here, I'm going to do it in black. That describes the line for A. I'm going to change colors here, so it's going to get confusing. So the next color I'm going to use is red. So tell me what happens when you subtract 2. Well, now it's a vertical shift down. How many? So that means, what do? So take the original line, and every point you're going to go down 2. So take a few points and go down 2 to create your line. Notice that these are parallel, aren't they? So shifting something up or down, the slope didn't change, did it? So that is B. I'm going to change the color again. It's going to be green. So tell me, but I'm going to write it in black, what's happening. Times 2, what does that do? So when you multiply, that's what's called a vertical stretch. So you stretch the y-coordinates by 2. So what do I do then? Well, you take a y-coordinate, a point, and you multiply it times 2. So if I take this original one, which is right here, if you multiply it times 2, it's now here. This is where 0, 0 times 2 stays the same. Oops, I was going to change the color. So here and here. Take another point, go times 2. And now you have an idea of what's happening. Now when it's negative, it's going to go down 2. So like negative 1 goes down to negative 2. I'm just looking at the y value. And negative 3 would be off my graph. Negative 2 would be 1, 2, more negative 4. Oh. Oop, this one's off. So negative 1 would be negative 2. Ignore that green one right there. One green one's off. And you have your line. So you can see the stretch. Did the stretch change the slope? Yes. So pay attention to the y-intercept, the x-intercept, and the slope. So the intercepts change when you shift it up or down. It's the slope that changes when you have a stretch. But the intercept stayed the same for the green one. All right, graph the next one. So the next one you see y, you see x squared being graphed. Can you graph and tell me what happens to the 3 in each one? So plus 3 means there's been a vertical shift up 3. So you take every y value, every point, and just shift it up 3. So I'm going to do that. I'll do that in black. So now the vertex is at 3. And then that becomes 4. And then that becomes 7. And the other one would be off the graph. And then draw it from there. There's going to be a lot of parabolas on this grid. So try to not get confused by that. This one's going to shift down how many? So from the vertex, go down 3. Go down 3. Go down 3. This goes down to 6. And you have it. How about this one? What's going to happen here? So when it's inside, it's going to be a horizontal shift. And it goes in the opposite direction. So what direction is it going to go? It's going to go to the right 3. So take the original and go to the right 3. I might do this one in red. Right 3. So take each point and go to the right 3. It's going to be some overlap here. What happened here? Well, that's a horizontal shift left 3, in the opposite direction. So take every point from the parent and go to the left 3. Look, they share a point up there. The red ones do. Well, that's looking very artistic right now. Got one more. I'll do this one in green. What is 3x squared? Well, that's a vertical stretch. So that's going to make it look a little skinnier. So you take the y coordinates and multiply them. Now the vertex stays exactly the same, but when I take 1, I multiply it times 3, and it stretches up to 3. And the next one is 4. Well, if I go to 12, that's already off my graph. So I just have to use those, and I'm going to draw a skinny-looking parabola. And you can see what happened there with the green one. So this one was green, and then red, and black, and black. So you have a little guide there. Look at that. That is artistic. All right, turn the page. Can you graph the absolute value of x? Yes. So that's 0, 0, 1, 1, and it goes on in that direction. And that's also negative 1, 1, and it has the same slope in that direction. So it looks like a V. Then what happens when you go plus 3? So sketch it and graph the transformed one. So what does that tell you to do? Well, that tells you there's a horizontal shift in what direction? We're going to go to the left 3. So I'm going to do that in red. So I'm going to take every point, instead of at 0, 0, if I go to the left 3, here we are. And again, take every point and do that, and then draw it over again. And then the black is the parent, and the red is the transformed one. Number 4, 2 to the x. What does that look like? So that's exponential. And so we have a point at 0, 1, 2, 4, or 1, 2, 2, 4, and it curves up to the right, and then it's going to flatten out to the left. There's my exponential graph. And there's an asymptote at 0. So what happens when you have negative x? What does that do? So notice it's in the exponent. It's going to affect the x coordinate. And every x, the sign is going to change. This causes what's called a reflection. And if the x changes, it's going to reflect across the y-axis. Because x positive, x negative, that's across the y-axis. So I take each point and reflect it across the y-axis. So the first point stays the same because it's on the y-axis. But the next point, I'm going to do it in green, will be on the left, and over here will be on the left. And this curve in green, because of the negative x, gets reflected and looks like that. Now the end behavior has changed. The asymptote stayed exactly the same. Number 5. X squared, let's graph that. That's a parabola. 0, 0, 1, 1, 2, 4. And what happened here? Oh, first of all, negative, 1/2, and 5. That's 3 things that happened. So what about the negative? Well, that reflects. And because it's on the outside, it reflects across the x-axis. How about the 1/2? Well, that creates what's called a vertical compression. And that's by half. So every y coordinate gets squashed down to half. How about the plus 5? Well, plus 5 means there's a vertical shift and everything's gone up 5. So if I take 0, 0, and I reflect it on the x-axis, stays the same. Half of 0 is still 0, but add 5, that now is at 5. So we're going to take the vertex 1, 2, 3, 4, 5, and that's now up there. How about take another point, like 1. It's going to be a little trickier, but if you reflect it and multiply it, so if I reflect it and then half of it, and then went up 5 from there. So if I reflected it down, then half, and then counted up 5, where would I end up? And the answer is you'd end up right there. And then you can reflect over on the axis of symmetry and find the one on the other side. Let's try that again with easier point. The y-coordinate there is 4. Notice all of this transformation is the y value. The x stayed the same. So the y value here is 4. So if I reflect it, it goes all the way down to negative 4. But then half of negative 4 gets me back up to negative 2. And then from negative 2, I add 5. And then I have my point. And then I'm going to reflect it on the other side. And then you can see what happens. So the parabola is a little wider, and it's no longer concave up, it's now concave down. And it's been shifted up 5. Looks like some aliens from, what's that game? Galaxia or something. No, I forget the name. Space Invaders. Something like that. 6. 1 over x. What does that graph look like? So just 1 over x, well, that has asymptotes on the x and y axes. The one point I'm going to focus in on is at 1, 1. And then it goes up forever and follows forever. So at the vertical asymptote, it goes to infinity. At negative 1, it goes down to negative infinity and then flattens out where the end behavior on both sides is 0. That's 1 over x. Now, what happens with the negative? What does that do to the graph? Well, it takes my 1, 1, and it's the y-coordinate that changes. So it's a reflection across the y-axis. Or the x-axis, I mean. It's the y value that changes. So instead of up, it's below. So for this one, I'm going to do it in green. That y value now is here at negative 1, and the negative 1, when you go negative, now becomes positive. So there's a reflection over it. It changes what quadrant it's in. Notice the asymptote stayed the same, but the graph has been reflected over the x-axis. So what was above is below, and what's below now is above. Logarithm. Hey, how do we graph this logarithm? So I just want to graph log x. So I'm going to remind you of some point on log x. So for log x, a point that's on there always for the parent is 1, 0. And another point to consider is the base and 1. And the base is 10. So I'd have to extend here to understand that it's somewhere way here in terms of it. Now it goes down forever. It kind of looks like that. It'll eventually be at 1 when it's 10. Now, what happens when you go negative 1 in front of it? Well, that causes a vertical shift down 1. So I'll take the 1 point I came up with here, and I'm going to go down here to negative 1. So this shape is still going to stay the same. And you can see the whole graph just has been shifted down 1 for the logarithm. Sine. Can you just graph sine for me? So if I graph sine, it starts in the middle. Now, the scale is interesting here. Pi over 3 and 2 pi over 3. But I'm going to go to pi, so that I know the value of sine at pi is also 0. Exactly in the middle here, it goes up to 1. Negative pi is 0. Exactly in the middle here, it goes down to negative 1. So I find the scale awkward, but we're going to deal with it. So there's the wave of sine. What happens when you multiply it times 2? Well, all the y values have been multiplied times 2. What happens when you add pi over 2? Well, we know that's a phase shift, and it goes in the opposite direction. So when I graph this, I'm going to start at negative pi over 2, which is right in the middle. And it starts in the middle, right there. And then when I multiply, the y-coordinate here is 0. So multiplying it times 2 stays the same. When I follow my pattern, because everything's been shifted to the left, this now is no longer the middle. It's now the top of my wave over here. It's been shifted over, and now is not 1, but it's been now multiplied times 2. This has been shifted over. We don't have something here, but if it's been shifted over, this would actually be the bottom of the wave of a point you don't see that's been shifted over. Here, this point's been shifted over and is now at negative 2. And that's what the new graph looks like. So it's been shifted, and the amplitude has been stretched. So there's been a vertical stretch of 2, and it's been shifted to the left, pi over 2. All right. This page is all about practicing, evaluating. Some will be super easy. Some you'll have to think about. So for each one, I want you to plug in different values. So negative 2. So if you plug in negative 2 and then answer it. So negative 2 plus 5, 3. And the absolute value of 3 is 3. In fact, I'm going to do this just to organize it so I don't run into the problems beside. All right, now it's organized. F at 0. So for 0, plug in 0, and you get 5. Plug in 1, and you get 6. Plug in 3, and you get 8. Same function, absolute value. Oh, we're going to start with negative 2. Notice here the absolute value of negative 2 is 4. Plug in 0. Well, the absolute value of negative 2 is 2. Plug in 1. Well, the absolute value of negative 1 is 1. Plug in 3. And that's just 1 again, and the answer is 1. Gives you the same answer. 11, a little more fun. So plug in negative 2. So that's negative 2 times the absolute value of negative 2. So that's negative 2 times 2, which is negative 4. So recognize the absolute value is going to change to a positive answer number. 0. Well, 0 times the absolute value of 0, that's a 0. 1 times the absolute value of 1 is 1. And 3 times the absolute value of 3 is 9. Number 12, 3 to the negative 2. So a negative exponent means reciprocal, so it's 1/9. 0, any base to the exponent 0 equals 1. 1, well, 3 to the 1 equals 3. 3 cubed is 27. So feel free to try these first and then press the video if you need it, or you can look on the answer key too. Negative 2. Well, negative 2 plus 2 is 0, so that's 1. 0. 0 plus 2 is 2, so it's 3 squared, which is 9. 1. 1 plus 2, that's 3 cubed, which is 27. 3, so 3 plus 2, that's 3 to the 5. That's going to get above my pay grade soon. So it's 81 times 5. 405. I guessed that. Let's make sure I did that one right. Oh, 243. Ah, wrong. 243. 14. Plug in negative 2. 3 to the negative 2 plus negative 2. So that's 1/9. Take away 2. You need common denominators. So we're going to multiply times 9. So it's 1 take away 18. So that's negative 17 over 9. 0. 3 to the 0 plus 0. Well, that's 1 plus 0, which is 1. 1. 3 to the 1 plus 1. That's 4. 3. 3 to the 3 plus 3. That's 27 plus 3, which is 30. It's good practice. 15, x divided by x. Well, if you take any number and divide it by itself, it's always going to equal 1 unless it's 0. Now, when it's 0 divided by 0, we're going to call this indeterminate. Which means, I don't know. Nothing divided by nothing. It's not undefined. It's like, I don't know what nothing divided by nothing is. It's special. All right, next one, 1. It's undetermined. Indeterminate. Indeterminate. One of those. 1. Well, that's 1. 3. 3 divided by, all that's going to equal 1, right? And the only spot here that's indeterminate is 0 over 0. All right, 16. Plug in negative 2. So that's negative 2 over negative 6, which is positive 1/3. Plug in 0. So that's 0 divided by something. 0. 1. That's 1. And that becomes negative 1/3. 3. So that becomes negative 3. 3 divided by negative 1. 17. Plug in negative 2. This one, I know, negative 2 divided by 0, that one is undefined. Plug in 0. Well, 0 divided by 2 is 0, and then subtract 5 and it's negative 5. Plug in 1. That's 1/3. Take away 5. I need common denominators, so I'm going to multiply by 3. So 1 take away 15 is negative 14 over 3. Is there another one? 3. So 3 over 3 plus 2 take away 5. So I have 3 over 5. I need common denominators, so I'm going to multiply by 5. That's 25 over 5. And then subtract, and you get negative 22 over 5. 18. Plug in 1. Whenever you evaluate a logarithm, plug in negative 2. So when you evaluate a logarithm, you can't have a negative number inside it. So that's a review and reminder. When you plug in 0, again, you can only have a positive number inside a logarithm. So 0 and negative 2 are undefined. The next one is 1. So when you evaluate a logarithm, you're finding the exponent. So 3 to what exponent is equal to 1? So that's 0. And then here, 3 to what exponent is equal to 3? So that's 1. Here, know that when the log and the base here are the same, these actually cross out and just leave you with x. That's a property. So this is the same as just saying f at x equals x. Or you can understand to bring it in front, but that's a property that the base and the base inside, they undo each other and leave me just with that exponent, which is x. So when I plug in negative 2, the answer is negative 2. When I plug in 0, it's 0. When I plug in 1, it's 1. And when I plug in 3, it's 3. It's just a line. Last one. So understand that log 1,000 base 10, this is an exponent. So what exponent? 10 to the exponent 3 is 1,000. So just 3x. So that when I plug in negative 2, it's negative 2 times 3, which is negative 6. Plug in 0, and the answer is 0. Plug in 1, and the answer is 3. And if you plug in 3, the answer is 9. So there is your homework to do with functions. Great job finishing this to the end. It is good skill practice to do this. Mr. G Math, over now.